switches. You guys have been working with the 2960s, right? Keep that status quo. All right. And I'm just going to go into these and change them here. Because this is just fast that way. But if you want to do the commands, it's totally cool. You can do it that way. This is just for expedience. If you don't know how to do a host name on a router by now, I think you got a bigger problem. All right. So switch 1 is the host name for this switch, switch 2, and switch 3. It's actually SW1. All right. Next, what you want to pay attention to is it tells you, it's kind of hard to see from a distance, but if you're looking at this on your computer, right, it tells you what interface is what. So the ISP is going to connect fast Ethernet 01 to fast Ethernet 00 on R1. Okay? So with that, since I'm going router to router, for it to work, I actually have to use a crossover cable, which is the dash line. And we'll go from fast Ethernet 01 to fast Ethernet 00. That's the only crossover that you have to do. All right? Everything else is just a straight Ethernet cable. All right? If you look at this, so 01 goes to 10. Or 01 here, just fine. And then 00 and 00 go into that one as well. Again, it's more about the router port, not the switch port. Okay, so don't worry about that. Here. Okay. All right. All right. So from here, what I like to tell everybody to do, because if you look at task number 1 and task number 2, I've actually already done task number 1. Configure all routers and switches with the host names depicted in the diagram. Did that already. Task number 2, configure all routers and switches with the IP addresses depicted from the diagram. All right, well, I got all the connections done. All right. Now I need to go into each individual interface and give it its right IP address. So starting from the top on the ISP router on fast Ethernet 01, I need to give it IP address 201.68.109.97 the /30 subnet mask. Oops, wrong one. All right. So I'm going to CLI. And F01. IP add. And it was 201.68.109. And what is the subnet mask for a 30-bit subnet mask? Anybody? I'll give you a hint. 255.255.255. Something. You guys know how to figure that out? Yeah, you can probably Google it. But if 255 is where all the bits are ones, right? And I have 8 bits, 16 bits, 24 bits. I need to get to 30 bits. I add everything up from left to right.
Is it
Right?
253?
Huh?
253?
Close. You're one off.
252.
252. All right. And the last thing I need to do is I need to turn the interface on. What's the command to turn the interface on?
No shut.
No shut. Cool. All right, so that's the ISP router. It's done. R1. Do a couple interfaces. 0, 0. Oops. Interface 0, 0 is actually connected to the ISP router. So it's going to be 201.68.109.98. Just make sure you get it right. 201.68.109. 201.68.109. And same subnet mask. And turn it on. Okay? Now I have connectivity between my ISP router and R1. How do I check that? Okay. Right. Ping 201.68.109.97. There we go. Cool. Oh, wait, I'm not done with R1 yet. The other interface fast Ethernet 01, has an IP address of 201.68.109.129/25. So IP add 201.68.109.129. And what is the subnet mask of a /25? 255.255.255. What? First bit in the last octet. So that is denoted by,
Or
no, the first bit,
128.
counting from the left,
128.
128. Turn it on. Cool. All right, R2. All right. 201.68.109.130 on fast Ethernet 00. Same subnet mask, 255.255.255.128. Oop. That helps if I put the command in, right? If I get to the interface first, then put the command in. Do it right. There we go. Turn it on. All right. And its fast Ethernet 01 is 192.168.50.1. with a 24-bit subnet mask. That's pretty easy. 255.255.255.0. And on. And last but not least, we have R3. And has an IP address of 201.68.109.131.128, since it's participating in that middle network. And its interface F01. Oh, I didn't turn that. Did I turn that on? No, I didn't. It's okay. I'll come back to it. 01 has an IP address of 172.21.0.1, as you can see right down here, with a 24-bit subnet mask. Turn it on. Go back to fast Ethernet 0. How I'm doing this is I'm setting the up and down arrows, guys. I don't know if you knew that or not. Go back to int F00. Turn it on. All right. If you're ever confused, you can do a show IP int brief, and it'll tell you that they're up or not. Okay. So now from R3, I should be able to ping 201.68.109. Did I get that back? .129. There we go. And 130, which is R1 and R2 respectively. So I have connectivity. I now have connectivity, you know, in this network through this switch to each one of these. Okay. All right. So my IP addressing is, for the most part, done. Okay, on the routers. On the routers. The switches do not have IP addresses. You don't have to worry about them. They're just, well, actually, I apologize. The ones down here do. The ones down here do. Switch 2 and switch 3 have IP addresses. Okay. I do not specify VLAN information, so you can just put them on VLAN 1. So I'll go to switch 2. And VLAN 1. 192.168.50.2. Show panel VLAN 1, see if it's up, and we just try to do a ping. Alright, I can ping myself, I can ping my router. I sure can. Alright? Switch 3, same story. Just have to worry about VLAN 1 and VLAN 1. 172.21.0.2. Turn it on. Ping myself. My router. There we go. So I now have IP addresses on everything. I have not done anything down here. We'll get to that at a later date and time. Okay? Questions so far? I've just thrown routers into Packet Tracer. Okay? Put IP addresses on interfaces. That's it. All right? I basically have gone through number 1 and number 2. Number 3 is the one that is going to kick everybody's butt. Okay? This is where you have to incorporate routing protocols within the network. And if you've not worked with routing protocols, All right, let me ask this question, and please be honest, I won't mock you much. Who has not worked with routing protocols on a router? Who's not? Seriously. Okay, cool. No worries, no worries. Everybody else has? No? Then why don't you raise your hand? I don't want to raise my hand, Fred Brown. You're scary. All right. Don't worry about it, all right? Once you get the hang of it, and this is kind of works regardless of router. It works the same way in Brocade, it works the same way in Juniper. You just have to learn the syntax. All right? It's going to be different from platform to platform. All right? But kind of turning on OSPF or turning on RIP or turning on BGP is kind of the same in each router. You have to tell it what protocol to turn on and what networks are participating in the protocol, and that's about that. The routers do everything else. All right? The only difference is, oops, this one here, EIGRP. EIGRP is a proprietary protocol that is only used by Cisco systems. All right? Only used by Cisco systems. So I kind of do that on purpose. Let's go into R1 and R2 and R3 and turn these protocols on. There's no protocol that's running here on the ISP. We just need a static route. We'll get to that here in a little bit. All right, but question number 3 says, configure the routing protocol domains according to the diagram. Ensure you have full 100% connectivity between all routed networks. Note that route redistribution will be required to complete this task. Full connectivity is validated when pings from R1 are successful to all of these addresses. All right, and so you basically got to ping all those. All right, now I don't need you to check that, because when you send me the packet tracer file, or when you send me the config files, if you're doing this on real equipment, which is cool too, I'll be able to tell. I'll be able to tell. All right, so again, let's work from the top. R1. All right, you want to be in global configuration mode. I'm going to kind of go back and forth here. R1 is only participating in OSPF area 0. All right? So the command to start OSPF or any protocol is the command router. And then the protocol. All right? And from here, there are subtle differences between manufacturers. All right? It's going to ask, a Cisco router is going to ask for the process ID. My process ID is 100, OSPF 100. And I hit enter. You notice the prompt changes to routing protocol configuration mode, or config-router. All right? And all I would need to do from here is tell it what network or networks are participating in OSPF process ID 100. And I also have to tell it, because it's OSPF, what area that network is joined to. So I do that with the network command. All right, then the network number, 201.68.109.128. Now, this is a point of confusion. You want to tell it the network number, not the IP address on your interface. The network number, not the IP address on your interface. I'll say that one more time, because I know it takes 3 times to sink in. Your network number, not the IP address on your interface. So the network number is 128. And then you got to give it the wildcard mask. So your subnet mask on your interface was 255.255.255.128. Anybody want to take a stab at what the wildcard mask would be, which would be the inverse of the subnet mask, right? 0.0.0 something, right?
128?
What's 255 minus 128? It's okay. That's why I always keep a calculator handy. and then I've got to tell it what area is participating in this case, area 0. All right? There we go. Guess what we do? We do the same thing on R2. We do the same thing on R3. Uh, 201.68.109.128. Everybody follow that. Watch what happens. I got a syslog message. That means you did it right. Okay? For those of you who studied OSPF in 347, you understand that routing protocols, all right, especially link state protocols, create an adjacency between routers that are participating in the same process ID and the same area or domain, using something other than OSPF, like ISIS. Okay? That's what that statement basically says. Hey, I have formed an adjacency with a neighbor in OSPF process ID 100 with the IP address of 201.68.109.129 via fast Ethernet 00. And I just have loaded its route database, and I have a full connection. Okay, so that's what that means. Now, I also have another network over here. I have the 192.168.50/24 network in EIGRP Autonomous System 25. All right, so I need to set that up. So I need to get out of OSPF by typing exit, and then do router EIGRP, the autonomous system number, which is 25. Router prompt changes the same thing. I'm still in a protocol configuration mode. And guess what the command is to add that network? Network, just like OSPF. I'll try to confuse you guys. 192.168.50.0, again, the network number. And it's wildcard bits. Now, wildcard bits for a 24-bit network, pretty easy, right? 0.0.0. what? 255, the inverse, right? Now, after that, I don't have to tell it any kind of area because EIGRP is not dependent upon area. So I say return. Cool. We'll come back to R2 in a moment. On R3, I need to do the same thing. But again, I'm only working with OSPF. I don't have EIGRP or anything crazy like that over here.
So you only need that on R2?
Huh?
You only need the EIGRP on the R2?
That's right, because that's what my topology says. I don't have EIGRP over here. I don't have EIGRP over here. I don't have EIGRP up here. It's only coming off of R2. Good question. Very good question. So on R3, router OSPF, process ID 100, and tell it my networks. Network 201.68.109.0, wildcard mask 0.0.0.127, area 0. You got that? Watch what happens. Come on. Uh-oh, something goofed. I typed the IP address in there, right? 201.68.109. Ah, look, I goofed. Okay, I did that on purpose. So I want to show you what you do when you make a mistake. You make a mistake, fine. You go back to the command, you put no in front of it. That takes it out. Okay? Oh, epiphany, I saw a light bulb come on. All right. Geez, I wish I would have known that for lab 1.
Yes.
That's okay. I didn't mark off stuff on lab 1 because of that. All right? Do it again, let's fix the mistake. So it's not dot 0, it's dot 128. Now watch what happens. Come on. Don't make me look stupid. There we go. I've not only made an adjacency with R1, I've also made an adjacency with R2. Cool? Now I have one more network to put in there. Net 172.21.0.0 0.0.0.255, which is the wildcard mask of that network. But what area is that network in? Look at the diagram. On there. It's in area 1, not area 0, area 1. Okay? Cool. All right, so now that I've gotten all that information in there, I need to go out here and go, okay, I got to go to R1 and ping all this stuff. Well, let me tell you a little bit of a shortcut. If I go to R1, I could start pinging all this stuff. I could ping 201.68.109.130. I already did that, right? And I did R3. Let me go ahead and ping the 172 network, 172.21.0.1, which is the inside interface of R3. And I can hit that. I also probably hit 2. No, I can't hit 2. Well, I goofed something there. That's easy to fix, okay? On switch 2 or switch 3, I have to give it a gateway. All right? Or an IP route, either way it will work, all right? IP default gateway 172.21.0.1. That's right. Yeah, 0.1. All right. Now I go back to R1. Try that again. It works. Right? Cool. All right. Now let me go ahead and ping. What was the other one I ping? Oh, the 192 network, right? 192.168.50.1. That's R2's inside network. Oh wait, that doesn't work. All right. Well, let me ping .2. Maybe .2 will work. Huh, that doesn't work. Oh, I have to put the gateway in, right? Okay, I'll put the gateway in. Oh, it doesn't switch to not R2. Oops. IP default gateway 192.168.50.1. Okay, which is the IP address of R2. All right, now go back to R1. Try this again. Still doesn't work. So we give you a hint. If .1 doesn't work, .2 is not going to work either. Okay? Here's why. The command show IP route will show you the entire routing table. Okay? I see that I have these two networks connected. This is the connection to my ISP. This is the connection into OSPF. I see the 172 network because it's an inner area network via R3. What do I not see? I don't see the 192.168 network, right? Here's why. It's a different routing protocol. Remember? You have to use route redistribution. Here's how you do that. This is redistribution one way. You only have to do redistribution one way. You've got to tell OSPF in R2 that EIGRP in R2 exists. And to take the networks from EIGRP and what we call inject them into OSPF. Okay? Alright, so I'm going to router OSPF 100. Guess what the redistribution command is? I'm not trying to trick you guys. It's really easy. Redistribute. Alright, what am I redistributing? EIGRP, right? It's kind of intuitive. What's the autonomous system number of EIGRP? 25, right? I can hit return here, and it will work just fine. Okay? And you'll get full points, nothing get taken off, but I just want to highlight this because it's important. Because I'm using a 192.168 network, which is a actually seen as a Class C. Okay, if you look at the classful network boundaries, it's going to take the subnet mask, it's going to inherit the subnet mask from those classful boundaries. It's going to work. What's best practice is to always include subnets after this command. So if you're working like with a 10net or another network that is not classful, it will look at the subnet mask bits